Bright Tuty. Every student matters.
Hello students, in this lecture we will be starting with the fourth chapter of your syllabus, and the chapter is heat. Students, you must have experienced heat in your daily life in different situations. For example, when you touch a pan which has hot water in it, or when you step out of your house in summer season, you feel really hot, right? So what is causing you to feel hot? What is the factor that is present which is making you feel hot, right? There's a picture in front of you which is of sun, and during summers you feel really hot outside, right? If you are inside in an air conditioned room, and if you move out of that room, you seriously feel that there is hot outside, right? And during winters your houses remain cold, right? But when you move out in the sunlight, you feel little warm, right? Sunlight helps during winters. So this is somehow related, right? There is some factor responsible for the heat or cold that you feel, right? So that is what we are going to study in this chapter. Let us start. As I told you, as I gave you some daily life situation, during summers you wear these kinds of clothes. In the box 1, this is the box 1, and in the box 2, there are some clothes that are worn in the winter season, right? Now what is the difference in between them? During summers you want the air to pass through your clothes, right? The clothes should not trap air. So these clothes do not trap air. Now students, you have to understand that air is a poor conductor of heat. You will be studying in coming lectures that what are conductors and insulators. Basically, conductors are those substances which allow the transfer of heat from them. Basically, for example, there is a pan of iron. So if you heat that iron pan, and if the handle is also of iron, you will notice that after some time, the handle of that iron pan also becomes hot, because in the iron pan the heat travels from here to here. Basically, this iron is allowing heat to pass through it. Similarly, air is a poor conductor. Basically, air does not allow heat to pass through it. So what happens in the woolen clothes? Woolen clothes trap air inside them. Wool has gaps and air is trapped inside them. So when the woolen cloth is touched on your body, due to the warmth of your body, the wool turns hot, and the air present inside wool also becomes hot, right? And this air is not allowed to move outside. The wool traps the air. So the air remains inside, and air is a poor conductor. So air does not allow the transfer of heat any further. Air is hot, but it does not allow the transfer of heat outside. So this is the difference, right? In summers we wear clothes which allow the transfer of heat, while in winters we wear clothes which do not allow the transfer of heat. They trap the air, and the heat is also trapped simultaneously. So these are some daily life situations which are related to heat, right? Let us start with the first topic then, hot and cold, right? You can definitely recognize different objects as hot and cold. For example, if you have kept a bottle of water in freezer, it will be cold for you, right? When you hold it, you will feel that the bottle is cold. But when you keep water boiling in a pan and you touch it after some time, you will feel that it is hot, right? And now you have taken water that is at normal temperature. Now what do you understand? Basically, there is a difference in some factor which is making something cold and something hot, right? There is presence of something that is causing this. Then how can we measure this degree, right? I gave you a simple example. And hot and cold, basically, you can also understand with the help of seasons, that summer is a hot season while winters is a cold season. So what is the difference? What is creating this difference between hot and cold? And also, these hot and cold are relative terms. Basically, you cannot be certain about something to be cold. That thing will not always be cold for you, while something hot will not always be hot for you. Let us see.
Sensations of touch is not reliable to find the degree of hotness or coldness of body. Materials required: cold water, warm water, tap water, 3 large plastic mugs. Method: take 3 large plastic mugs and label them A, B and C. Pour ice-cold water in mug A, tap water in mug B and warm water in mug C. Make sure that water in mug C is not very hot and your hand bears it. Now dip your right hand in mug A and left hand in mug C and wait for 2 to 3 minutes. After 2 to 3 minutes, take out your hands from mug A and C and dip them in mug B at the same time. You find to the left hand the tap water will appear warm, whereas to the right hand the water appears cold. Conclusion: thus, the activity clearly proves that our sensation of touch is not reliable to find the degree of hotness or coldness of the body. The reliable measure to find the degree of hotness or coldness of the body is to measure its temperature. The device used to measure temperature is called thermometer.
Conclusion from the activity is that hot and cold are relative terms. What do you understand by this statement? This statement tells us that one body can be hot, but there can be another body which is hotter than it, right? And there can be a body which is cold, and there can be another body which is colder than it. So these terms are relative. We cannot fix a word hot to something, right? Because the normal water that we just saw in the activity was acting hot for our left hand and acting cold for our right hand. While it was the same, right? It was not hot or cold, it was normal. So this tells us that hot and cold are relative terms. We compare things with these terms, right? That this thing is hotter than this thing is colder than this. These are relative terms, alright? We cannot fix these words to something, right? Now what is the factor that lets us measure this degree? That is temperature. The quantity by which we can compare the hotness or coldness of bodies is called temperature. Temperature is basically the quantity that helps us measure the hotness or coldness of bodies. For example, boiling water, the temperature of boiling water is 100 degrees Celsius, while the temperature of normal water is 25 to 30 degrees Celsius depending upon the room temperature, right? Normal water has the temperature of room temperature, and ice water has the temperature of 0 to 2 degrees Celsius. So now you can understand, higher the temperature, higher is the heat content, higher is the hotness of the body. While the lower is the temperature, it is colder than other bodies then. For example, ice water has lower temperature than normal water, so it is colder. While boiling water has higher temperature than normal water, so it is hotter, right? So this temperature is allowing us to compare the degree of hotness or coldness of a body, right? So temperature is the quantity that helps us measure. Now how do we measure the temperature? Now to measure the temperature, we use an instrument called thermometer. Thermometer is the instrument used to measure temperature. Now in front of you we have clinical thermometers. We'll be discussing about these in detail in the second lecture. Basically you have to understand that these are clinical thermometers. These are used by doctors to measure body temperature, right? This is how it looks. There is a cap in front of it which has metal or mercury inside it. There is a kink in clinical thermometers, and then there is a scale on which reading is present. And what is this reading? Basically 35 degrees Celsius to 42 degrees Celsius. This is the range of this clinical thermometer. And this is a clinical thermometer, but this is digital in nature basically. It is not normal manual thermometer. It is digital thermometer. It displays the temperature. And as you can see, the temperature has been displayed in Fahrenheit. So this was the Celsius scale, and this is the Fahrenheit scale. So there are two scales. As you know that for measuring distances we use mile and kilometers, right? Miles and kilometers. They are both used to measure distance, but they are both different units, right? Mile is greater than kilometers. So that is similar in this case. There are two units in which you can measure the temperature, and those two units are Celsius and Fahrenheit. There is Kelvin as well, the third scale, but we only have to understand two scales here, which are Celsius and Fahrenheit. Alright, so what did we conclude till now? That there is a metal cap on the top, and then we have a glass tube, the bigger glass tube, and there is a glass tube inside as well, right, in which the mercury rises up to a level of the temperature of that body, right? The mercury only rises up to the temperature of the body. It does not rise any further. For example, in this picture, the mercury is rising up to 37 degrees Celsius. The temperature of the body will be counted as 37 degrees Celsius. We'll be studying about measuring a temperature in the separate topic. You just have to understand that this is a thermometer in which mercury is present, in which manual thermometers, the mercury is present, which rises upwards as you bring it near a body, right, according to the temperature. Now, Celsius and Fahrenheit scales. As I told you, there are two scales which are used to measure temperature, right? Now, there is a relationship between both of them, and the relationship is the temperature in Fahrenheit will be equal to the 9 by 5 times of the Celsius temperature plus 32. Right? This is the relationship between Fahrenheit and Celsius scales. For example, if the temperature in Celsius has been given to you as 30 degrees Celsius. Now, how do you tell what is the temperature in Fahrenheit then? Let us calculate according to the formula. We put the value of Celsius in the formula, 9 by 5 into 30 plus 32, right? So the value comes out to be 5 6 are 30 and 9 6 are. So basically you simply have to calculate, right? So as we know that simply the relationship between Fahrenheit and Celsius is F is equal to 9 by 5 into C plus 32. So simple calculation has to be done by simply putting the values. There can be the values of Celsius given to you as well as the value of Fahrenheit can be given to you. Value comes out to be 9 6 are 54 plus 32, right? The temperature comes out to be 86 degree Fahrenheit. So 30 degrees Celsius is equal to 86 degree Fahrenheit. This is the relationship. This is the value that comes out after the calculation. So the relationship is this, right? This is how we calculate. Now, interconversion of Fahrenheit and Celsius temperatures, as I already gave you the example, F is equal to 9 by 5 Celsius plus 32. Now students, always remember that Fahrenheit temperature is always greater than Celsius temperature. In any values, Fahrenheit value will always be greater than Celsius value. So if you forget the formula, always remember that Fahrenheit has to be greater than Celsius. So Fahrenheit is on the left hand and we multiply Celsius by 9 by 5. Not 5 by 9, 9 by 5, because it is 9 by 5 is greater than 1. As you know, 9 by 5 is greater than 1. So multiplying it by C, when you multiply something by more than 1, the value comes out to be larger, right? So you simply have to remember that this is the formula, and always Fahrenheit value will be larger than Celsius. Taking another example, for example, the temperature has been given to you as 50 degrees Celsius. You have to calculate it in degree Fahrenheit. What is the value? Putting the values again, 9 by 5 into 50 plus 32. This is simply 10. Then 90 plus 32 is equal to 122 degree Fahrenheit. So basically 50 degrees Celsius comes out to be 102 degree Fahrenheit. As you can see students, that the value in degree Celsius was 50 only and the value in degree Fahrenheit is 122. So the value of Fahrenheit comes out to be greater than Celsius value always, right? Is something that you have to learn. This was the first topic of this chapter in which we learnt about the hot and cold, that they are relative terms, and also about temperature and how we measure temperature with the help of a thermometer, right? Also, we learned about Celsius and Fahrenheit scales.